Hi everyone, welcome to today's class on Is Matter Around Us Sphere. In the last chapter, we had learned about matter, and we learned that matter can be classified into solids, liquids, and gases. And what is the basis of this classification? The attractive force. And the attractive force is maximum in the case of solids, minimum in the case of gases, and intermediate in the case of liquids. You know what intermediate means? In between. It's not as high as in the case of solids, not as low as in the case of gases. Now, in today's class, we will try to classify matter on another criterion, not on the basis of attractive force, but on the basis of composition. It is just a classification based on another criteria or another base. So let's try to understand this in detail. This is common salt or sodium chloride. Common salt. You know that this is a compound. Why is this called a compound? Because it is made up of more than one kind of atoms. This is made up of sodium as well as sodium ions as well as chloride ions. And we also know that this is a matter. Now we have taken some water in a beaker. You know that this also is a compound. And why is it a compound? Because this is made up of more than one kind of atoms. It's made up of hydrogen and oxygen. And this also is a matter. Now what we do is when sodium chloride is dissolved in water, you get a solution of sodium chloride in water. We know that this is a mixture, and we also know that this is also a matter. So we realize that a mixture is a matter, compound like sodium chloride and water, they also come under matter. So both these are matters. So matter can be a compound, matter can also be a mixture. Okay, now let us take a look at this particular example. We have taken iron powder. This is made up of iron atoms. We call it an element because it is made up of just one kind of atom, that is iron atoms, single kind of atoms. So this is an element. It is made up of only one kind of atoms. And we also know that this is a matter, right? Similarly, sulfur is S8. This again is an element. It's an element because it is made up of same kind of atom, sulfur. We know this also is a matter. Now we mix iron with the sulfur. So here you can see a mixture of iron and sulfur. So this mixture, as we have seen in this case, also is a matter. So we have already seen that mixtures come under matter. Compounds like sodium chloride and water also come under matter. Now we have seen elements like iron and sulfur. They also come under matter. So what do we call these two together? Compounds and elements together. We call them pure substances. Pure substances. So now we can classify matter into two. One is mixture, other is pure substances. Now, pure substance can either be an element or a compound. Mixture can either be by mixing together two or more than two compounds, or two or more than two elements, or maybe combination of both. So this is how matter is classified on the basis of composition. Now let us try to understand these pure substances in a little more detail. But before we do that, take a look at this substance. This is formed when this mixture, iron and sulfur mixture, is heated strongly, and this is called iron sulfide, FeS, which is obviously, as we know, it's a compound. It's a compound, therefore this comes under pure substance. Now take a look at this. So we have seen that pure substances can be classified into elements and compounds. So we have seen example of compounds, examples of elements, and examples of mixtures. So let us consider some examples of elements. We have seen that oxygen is an element, hydrogen is an element, iron is an element, sodium is an element, carbon is an element. All these are elements because they're all made up of same kind of atoms. You can see oxygen is made up of oxygen atoms, hydrogen is made up of hydrogen atoms, iron made up of iron atoms, sodium is made up of sodium atoms, carbon is made up of carbon atoms. But there is a difference between these two elements and these elements. The difference is these elements are made up of their atoms. That means They exist in the form of atoms. But oxygen exists not as O, but it exists as O2. Hydrogen exists not as a H, but it exists as H2, and we call them molecules. And these are atoms. So you can see elements can be of two types. They can be either atomic, which means they exist in the form of atoms. Neon is an example. It exists as neon atoms. So neon is an example of atomic element. Carbon is an example of atomic element. Sodium is an example of atomic element. Iron is an example of atomic element. But oxygen exists as O2, and we call it a molecule of oxygen. Therefore, it's a molecular element. So it exists as molecular element. Now if you see compounds, we are saying sodium chloride and water. Now the difference is this will not get converted into its ions. So no ions from water. Ions means charged atoms. It will not give you H plus ions and O minus ions or 2 minus ions. So this comes under molecular compound. But sodium chloride gets easily converted to, when you put it in water, it gets converted to Na plus and Cl minus, or it is made up of ions. This is not made up of ions, so we call it ionic compound. So how do we classify elements? Atomic, molecular, based on how these elements are made up of. Compounds, molecular or ionic. So FeS is a compound. It is made up of Fe2 plus ions and S2 minus ions. Therefore, this comes under ionic compound. Let us try to understand more details. Now, we already understood what pure substances are. Pure substances can be elements. In this example, you can see helium atoms, and this is an example of water, which is a pure substance. So how do we know whether it is a pure substance or not, or what is the basis? Pure substance cannot be converted into its constituent atoms by physical methods. They cannot be converted. Physical methods, you cannot convert them into its constituent elements. So water cannot be converted into hydrogen and oxygen by physical means. But if you consider the mixture of sodium chloride and water, we can separate them easily by evaporation, which is a physical process. So here we can separate them into the constituent substances. Separate them into the constituent substances. We call them substances because it can be compound or elements. So helium is a pure substance. It is an element. It is atomic. Water is a pure substance again. It is called a pure substance because we cannot separate them into the constituent atoms by physical means. Let's try to understand more about the matter. So we have studied that matter can be classified into pure substances or mixtures. We had already classified a matter into solids, liquids and gases. This classification is based on the attractive force. We have once again classified matter. Now we have classified them into two, pure substances and mixtures. Here the classification is based on the composition. So in both these cases we have actually classified matter, but on two different criteria, two different bases. Pure substance you already understood can be either elements or compounds. Iron is an example of element. Sodium chloride is an example of compound. Now let us see how mixtures can be classified. Suppose we take a solution of sodium chloride. We have dissolved the sodium chloride into water. We get a solution of sodium chloride. Now if we taste this solution from different parts of the solution, you'll find the taste is same, which means the amount of sodium chloride which is dissolved or which is present at different parts of the solution is same, which means sodium chloride is evenly distributed. Evenly means equally distributed. Every part of the solution, the amount of sodium chloride and amount of water remains same. And if that is how this mixture is, we call it homogeneous mixture. Homogeneous. And when a mixture is homogeneous, homogeneous means the composition is same everywhere, we call it a solution. So solution basically is a mixture. But what kind of mixture? Homogeneous mixture. So homogeneous mixtures are called solutions. So sodium chloride is a sodium chloride in water mixture is a homogeneous mixture. So we call it a solution. Whereas if we mix some oil in water, you can see the composition is not same everywhere. You find oil only at this place, you find water only at this place, which means it is heterogeneous. So in heterogeneous mixtures, the composition will not be same everywhere, it will differ. Another example, if you put sand in water, this will make a heterogeneous solution, heterogeneous mixture, not solution, heterogeneous mixture, because sand will settle down at the bottom, so it will not be same at every part of the mixture, so it comes under heterogeneous. So see the classification once again. Matter on the basis of composition can be classified into pure substances and mixtures. Under pure substance we have elements and compounds. Under mixtures we have homogeneous and heterogeneous mixtures. When the mixture is homogeneous, we call it a solution. Let us summarize. We have learned that matter may be a pure substance or it may be a mixture. So matter can be classified into pure substance or a mixture. Pure substance may either be an element or a compound. Mixture may be either homogeneous or heterogeneous. This is how mixture is classified. And mixture may be composed of two or more elements. So it can be elements plus more elements. It can be two or more compounds, or it can be combination of both, element plus compound, any number of elements and compounds. So I hope you understood the concepts. That's all for today's class. See you in the next class.